We are on to our next unit notes. This unit is a very, very long unit, and it is all about the restless Earth. We're going to talk about things like plate tectonics, earthquakes, volcanoes, and Pangea, and how the continents were once one continent. This theory or idea that the continents all were one at one point. So here we go. Earth's layers. Now, Earth has two different sets of layers. They consider these two sets of layers. One is the chemical compositional layers, and the second group of layers are known as the physical layers. Now, obviously, the chemical composition layers are broken up based on the chemical composition of each layer. The physical layers are more about how they appear and their physical characteristics. So they're divided into layers. There's 3 compositional layers. Those compositional layers are the crust, core, and mantle. And then there's 5 physical layers, which is the lithosphere, the mesosphere, the asthenosphere, the inner core, and the outer core, which we're going to learn more about as we continue on. All right, let's talk about the crust. Now, the crust is a compositional layer. It is the outermost layer. There are 2 types of crust. There's continental and oceanic. Now, recall from our discussion in class that oceanic crust is more dense than continental. Reason being is because it holds more magnesium, which makes it more dense. They are both made up of oxygen, silicon, and aluminum, and then of course oceanic has a little bit more magnesium in it than continental crust does. So that's the crust in a nutshell. The mantle is the biggest layer. It takes up 2/3 of the mass of Earth, so it's extremely huge in comparison to the other layers. It is a layer of hot, slow-flowing solid rock. Convection is a huge movement of matter that results from differences in density caused by variations in temperatures. We're going to later do a convection lab that will explain to you how this how convection works throughout the mantle. We're going to do it with hot and cold water, and you'll get to see how that movement is created in the mantle, and you'll get to recreate that. Cooler rock will sink, and the warmer rock will rise. We will find the same thing in our lab, that the cooler water will sink and the warmer water will rise to the top. So it'll be pretty cool. Again, the mantle contains more magnesium, which makes it more dense than the crust in general. The more magnesium a layer has, the more dense it's going to be. That's not the only contributing factor to creating a high density, though. There are many other things that contribute to having high density. The core is the innermost layer. It extends from the mantle to Earth's center. It is the densest layer. As you go down in the layers, it gets more dense, higher in pressure, and of course hotter. So the core is the densest layer of all, and it is made mostly of iron. It does have some nickel in it, but majority of it is made of iron. And you will find out that the physical layers break the core down even further into inner core and outer core. The outer core actually is going to be the only liquid layer of Earth, which is pretty cool. The lithosphere is the first physical layer of Earth. It's the outermost physical layer, and it's the rigid layer. There's 2 parts to the lithosphere. There's the crust and the upper part of the mantle. It's not the entire mantle, just the upper part. The lithosphere is broken up into pieces, and those pieces are referred to as tectonic plates. So that layer is actually broken up into those tectonic plates, which we know causes a lot of different things, such as tsunamis, earthquakes, volcanoes, the continents moving. Just several things are affected when those tectonic plates begin to move. The asthenosphere is another physical layer of Earth. It's a layer of weak, soft mantle and slow-flowing rock. The tectonic plates, which are in the lithosphere, move on top of the asthenosphere. So the lithosphere is obviously on top, and then next is the asthenosphere. The mesosphere is again a physical layer of Earth. It's the strong lower part of the mantle. The rock flows slower here than the asthenosphere. The outer core, like I had said earlier, is the only liquid layer of Earth's core, and it surrounds the inner core. The inner core is a solid spherical layer, and then it's surrounded by that liquid layer. The inner core is solid and is dense center of Earth. It's extremely dense because, as I had said earlier, as you go into Earth's layers, it becomes higher in pressure, hotter, and more dense. All right, we're going to talk about a thing called continental drift. Again, continental drift is something that gets affected by the shifting of the tectonic plates. Continental drift is actually a theory, and if you recall, a theory is not necessarily true. It is a supported idea that scientists come up with. So continental drift is one of those supported ideas. And it's a theory that the continents have moved over time. They theorize that the continents started as one continent known as Pangaea, and slowly they drifted apart to have the continents we now see today. The things that support continental drift are the locations of the mountains. Several mountain ranges, if you start putting the continents together, line up. Rock formation doesn't make sense, or supports this theory, because you'll find different types of rocks in different continents that wouldn't necessarily make sense. It would have to be that they were at one time part of the same continent, which is the theory of Pangaea. Climate conditions also contribute to that. Different climate conditions, different species of fossils were found in different areas of the world, which again supported the idea that the continents were once one. The continental drift was not accepted until scientists began studying the seafloor. The seafloor gave a lot of new information for them. The seafloor slowly moves apart, and then as an effect, so do the continents. So once they started studying the seafloors, they started to determine that this idea of continental drift just may actually be correct. Plate tectonics. Plate tectonics is the movement of tectonic plates. Continents are all on plates that move with the plates. The lithosphere is broken up into the plates. They move on top of the asthenosphere. Those plates will vary in size, shape, and thickness, and they move, which also causes the continents to shift. Plate boundaries. These are where these tectonic plates meet. There are 3 different types of plate boundaries. There is convergent, divergent, and transform boundaries. The most dramatic changes occur along the plate boundaries. So when those plate boundaries shift and move, different dramatic events can occur, as we talked about earlier. Convergent boundaries are when 2 plates collide. They create a subduction zone when one plate sinks below the other. So you're going to have 2 plates colliding. One's going to go below the other. Divergent boundary is when 2 plates move away from each other. They're mostly located on the ocean floor. The asthenosphere rises to the surface and then melts. The asthenosphere cools and then forms a new lithosphere. So kind of cool that those layers kind of interchange. The asthenosphere will rise above to the lithosphere, it will melt, and then it forms that new lithosphere to form new plates.